Hello everyone, I Pratyavasti, Assistant Professor in the Department of Pharmaceutical Chemistry in Maharaja Agrawal University, Baddi. Today I am here to discuss about the nomenclature of organic compounds. First of all, I would like to discuss what are organic compounds. The organic compounds are the compounds which contain carbon in its molecule, whether they are exist in solid, liquid or gaseous state. For example, hydrocarbons. Hydrocarbon contain both carbon and hydrogen. For next example is carbohydrates, lipids, proteins, nucleotides. These all are the examples of organic compounds. Then we can discuss organic nomenclature of the organic compounds. We can name the organic compound by three methods: trivial, rationale, IUPAC. IUPAC means International Union of Pure and Applied Chemistry. First of all, we'll discuss trivial nomenclature. In this, the compound which were discovered by chance, they are named by their friend. For example, from their properties, by the source from where we get this product, like lemon from the citric acid, formic acid, these are. Okay. And now I will discuss rationale nomenclature. It was the nomenclature in which we consider the structure of the molecule. For example, methane. Methane is the common structure. Further, its structure will be like methyl. If we add methyl in methane, then its name will be methyl methane. And next similar is dimethyl methane. Now further, the IUPAC nomenclature. This is the most rational and widely used nomenclature in organic chemistry. The main feature of this system is that one molecular structure has only one name. And IUPAC naming for any organic compound will consist of three parts. First is word root, then suffix, and then prefix. Suffix and prefix both are further categorized into two parts, primary and secondary. First of all, word root. Word root is the basic unit of the naming of the organic compound. For example, like if we have one carbon chain, then it will be named by meth. Okay, word root is the number of carbon atoms present in the parent chain. It means we have to select the further, we have to select the longest possible carbon chain, including the functional group, multiple bonds of the organic compound. Okay, for chain from 1 to 4 carbon atoms, the special word roots will be considered by their common names of alkanes like methane, meth, eth, prop, but. And further, for chains of above 5 or more than 5 carbon atoms, Greek word roots will be used. For example, if we have a carbon chain of 1 carbon, then word root will be meth. If we have a carbon chain of 2 carbon, then word root will be eth. Further, if we have a 3 carbon chain, then the word root will be prop. If we have 4, then but. If we have a carbon chain of length 5, then it will be word root will be pent. And if we have a 6 carbon chain, then hex. If we have a 7 carbon chain length, then word root will be hept. If we have 8, then oct. If we have 9, then non. If we have a carbon chain of 10 carbons, then it will be a name, word root will be a dec. If we have a carbon chain of 11 carbons, then it will be named as undec, yeah, undeca. Okay, then carbon chain of 12 carbons, it will be a dodeca. Next is the suffix. Suffix, I previously also told that suffix are divided into two parts, primary suffix and secondary suffix. Primary suffix is always added to the word root to indicate the carbon chain, whether it is saturated or unsaturated. It means we have to add this for knowing that our compound is a single bond compound or a double bond compound. For that type, there is a flow table, type of carbon chain, primary suffix, and then its general name. If the compound is saturated, means single bonded, then primary suffix will be ene and general name will be alkane. If we have a compound of having one double bond, that means it's a unsaturated, then primary suffix will be ene and the general name will be alkene. If we have a compound with one triple bond, it means unsaturated with one triple bond, then it's ine and general name will be alkyne. If we have a unsaturated compound with two double bonds, then we will use the primary suffix, that is diene, and general name will be alkadiene. If we have an unsaturated compound with two triple bonds, then we will use primary suffix diene and the general name will be alkadiene. These are the following examples having a word root and primary suffix. For example, in first example, there is a 4-carbon chain, then its word root will be but, and primary suffix will be, because these are saturated compound, then the primary suffix will be ane, and the IUPAC naming for this is butane. And if we are using 3-carbon chain, 3-carbon chain length, and having a double bond on first carbon, then its word root will be 3-carbon है तो prop, और unsaturated with 1 double bond है तो ene, that is propene. नेक्स्ट इन नेक्स्ट का उसमें 2 कार्बन के बीच में एक ट्रिपल बॉन्ड है, इट मीन्स 2 है तो इथ, और एक ट्रिपल बॉन्ड है तो आइन, तो क्या बन गया इथाइन. नेक्स्ट वी आर हैविंग 4 कार्बन चेन with 2 double bonds, one is at first position and second will be at third, then its name will be butadiene. Next, in next example we are having 2 triple bonds, first at first position and second one is at third position, then we are having 4 carbon chain, it means word root will be buta, and here 2 triple bonds hai to diene, butadiene. Next is our secondary suffix. Secondary suffix is just added before primary suffix to indicate the nature of functional group which are present in organic compound. Okay, this is our table. In this class of organic compounds, functional group and secondary suffix which are used. For alcohols, functional group will be represented by OH and secondary suffix we will use OL. Aldehydes के लिए CHO functional group है and secondary suffix हम use करेंगे AL. Ketones, carboxylic acids like C double bond O for ketones, COOH for functional group होगा carboxylic acid का. Then secondary suffix on and oic acid will use. Acidamide is CONH2 and suffix we will use amide. Acid chlorides के लिए COCl and suffix we will use acid chlorides. Esters, similarly esters, nitriles, thiamines, thialcohols, amines we will use. These are the following examples illustrating the use of word root, primary suffix, secondary suffix in the naming of organic compound. First of all, first example having 2 carbon chain, that is word root will be eth, and we are having primary suffix. What will we use? Because these are saturated, then we will use primary suffix ane, and functional group is OH, that is alcohol, and we will use secondary suffix for that alcohol is OL, then name will be ethanol. Next example में 3 carbon chain है, एक NH2 group लगा है, NH2 group is amine, single bonded है, so it means primary suffix will be used as ane, and 3 carbon है तो prop, तो क्या बन गया propane amine, propanamine. Next में we are having 4 carbons, 1 carbon is starting from carboxyl group, then we are having 4 carbon chain, it means word root will be but, single bonded है तो ane, और कार्बोक्सिलिक एसिड का COOH है तो मतलब ओइक एसिड, तो क्या बन गया ब्यूटेनोइक एसिड. सिमिलरली नेक्स्ट एग्जांपल में CH3 CH2 CN, इट मींस 3 कार्बन चेन है तो वर्ड रूट हो गया प्रोप, सिंगल बॉन्डेड है एन, और NCN है तो नाइट्राइल, तो क्या बन गया प्रोपेन नाइट्राइल. नेक्स्ट में 3 कार्बन चेन है फिर से, और एल्डिहाइड ग्रुप है, डबल बॉन्ड भी है, इट मीन वर्ड रूट तो प्रॉप ही रहा, लेकिन अब यहाँ पे अनसैचुरेटेड है तो विद सिंगल डबल बॉन्ड है, इट मीन्स इन, और एल्डिहाइड का सफिक्स हम यूज़ करते हैं अल, तो बन गया प्रोपिनल. नेक्स्ट एग्जांपल में 3 कार्बन चेन है, एक सिंगल ट्रिपल बॉन्ड है और एक कार्बोक्सिलिक एसिड है, देन प्रोप, ट्रिपल बॉन्ड है तो आइन, और कार्बोक्सिलिक एसिड है तो ओइक एसिड, देन प्रोपेनोइक एसिड. नेक्स्ट इज आर प्रीफिक्स. Prefix भी further 2 types में categorized है. First is primary prefix. Primary prefix is just added before your word root, which will distinguish between that your compound is cyclic or acyclic, means it's in a ring form or a open chain structure. Okay, for example, in case of carbocyclic compounds, okay, carbocyclic compounds are those compounds in which only carbon atoms are present in the ring. In that case, we will use cyclo immediately just before your word root. For example, in this example, there is a one ring in which we are having 5 carbon chain. So it's all unsaturated, saturated, then cyclo and penta, because 5 carbon है, single है तो ane, तो क्या आयुर्वेदिक नेमिंग होगा cyclopentane. अगर आपका जो रिंग है, अगर आपका जो स्ट्रक्चर है वो रिंग फॉर्म में नहीं है, तो भी हम यहाँ पे साइक्लोवर्ड यूज़ नहीं करें, ये साइक्लिक है। नेक्स्ट सेकेंडरी प्रीफिक्स। सेकेंडरी प्रीफिक्स जो होता है वो हम कंसिडर करते हैं ऐसे फंक्शनल ग्रुप्स के लिए जिन्हें हम ट्रीट करते हैं एज अ सब्स्टिट्यूएंट्स के लिए, या कुछ ऐसे ग्रुप्स जो कि हम एज अ सफिक्स यूज़ नहीं करते हैं, और ये हम जस्ट ऐड करते हैं जस्ट बिफोर प्राइमरी प्रीफिक्स। For example, fluorine, chlorine, bromine, iodo, nitron, nitroso, diazo, alkoxy. These are the substituent groups which we will use as a secondary prefix. Further, methoxy, ethoxy, alkoxy, alkyl, ethyl, ये सब groups जो होते हैं इन्हें हम as a secondary prefix add. For example, organic compound of two organic compounds having two carbon chain, then its what it will be eth, and prefix is bromo, and these are single bonded means ene, it means bromoethane. Next secondary prefix is nitro, and word root, because single carbon hai to word root will be meth, and primary prefix will be ene, then your nitromethane. Next ethane, ethoxy group है present and word root है आपका eth, हो गया ethoxy ethane. In case of carbocyclic compounds, primary prefix will be also used. For example, if we are having a ring form structure and it's having a one substituent and one functional group also, then we will use first position पे है alcohol group and fourth position पे है bromo group. Then 4 bromo, because it's a cycle form, then cyclo, 6 carbon है तो hex, single bonded है तो ane, and एक OH group लगा है तो मतलब ol. It means 4 bromocyclohexanone. The sequence for IUPAC naming of organic compound consists of following parts. Like first of all, we will see in our structure, that is secondary prefix, then primary prefix, word root, primary suffix, and then secondary suffix. Then rules for IUPAC naming of complex aliphatic organic compounds, that is for complex saturated hydrocarbons, alkenes. For these we are having different rules which we have to follow. First rule is the longest chain rule. In this we have to select the we have to find the longest continuous carbon atom chain in the molecule, which we also call parent chain. For example, there are two structures. First, in left side we are having, if we select this, if we are having the 6 carbon chain, then our carbon chain will be hexane. Okay, if we select right hand side structure and the chain started from out, then we are having 7 carbon chain, so we will select the longest carbon chain, we will go with 7 carbon atom chain, that is heptane. Next rule is rule for larger number of side chains. If we have two different chains of equal lengths, then we will select that chain which are having larger number of side chains or alkyl groups. For example, in first structure we are having two substituents, but if we select another structure we are having one, then we will select a first one structure. Then next rule is the lowest number rule or lowest location rule. In this, number of carbon atom of parent chain we will number as 1 2 3 4 etc, but we will start the numbering from that side, from that end of the chain which carry the substituents. It means we have to number the chain with substituents. Lowest sum rule or lowest set of localents rule. If we are having two or more substituents present, then we will generally two rules we will follow. That is, first rule is lowest sum rule, another is lowest set of localents rule. Lowest sum rule में जब दो या दो से ज़्यादा सब्सटेंस प्रेजेंट होंगे तो नंबर जो होगा कार्बन एटम को, मतलब पेरेंट चेन के जो कार्बन एटम है, इस तरह से करेंगे कि उनका नंबर सम जो होगा वो मिनिमम आना चाहिए. फॉर एग्जाम्पल, in this, if the substituent present on 3 and 4th position, then their sum will be 7. And another structure, if you're numbering from below, then substituent will be present on 4 and 5, and their sum will be 9. So we will select the another structure. Similarly, lowest set of localents rule. Isme, when the two or more substituents are present in the parent carbon chain, then lowest set of localents we will select from all the possible directions. For example, in this, the substituents are present on 3 and 4 position, then we will select this. And if the localants are present in same structure at 4 or 5, then we will select with 3 and 4. And this is a similar example for the localist rule. Next is the name of the complex alkanes. In this, we will use prefix to indicate the position of substituent on the parent chain, in which the carbon atom carrying the substituents. Next, alphabetical order of the simple substituents. In this, when 2 or more simple substituents are present on the parent chain, then each prefix will be arranged in alphabetical order before the parent alkane. It means if we are having a chain of carbon atom, 8 carbon atoms, and we are having one methyl group on 3rd position and one ethyl group on 5th position, then we will naming it by alphabetical order. Means ethyl will come first before methyl. So its naming will be 5-ethyl 3-methyl octane. Next is the numbering of different substituents in equivalent positions. In this, when two different substituents are present in equivalent positions, then numbering of parent chain will be done in such a way that the substituent which comes first in alphabet order will get the lowest number. Like we are having two methyl groups on, one methyl group and one ethyl group on the same position, then we will number by alphabetical order. That is 3-ethyl 3-methyl pentane. Next is the naming of the same substituents in different positions. If we are having same substituents more than once on the parent chain at different position, then we will separate that substituents by commas. Like if we are having 2 methyl groups, then we will use di. If we have 3, then tri. If we have 4, then tetra. So in this example, one methyl group is present at 2nd position and one is at 4th position. Then we will naming like this 2,4 dash dimethyl pentane. Thank you. That's all for the today's session.